can hear you, Gail. Here, give me a second. How do I get you? Hey, there you are. Yeah, I can hear you, Gail, and I just don't think your sound. Let me talk. Yeah, 1 second. I gotta figure out how to get your audio to go through. Yeah. Okay, just give us a second. This is our first time doing. We're trying to get Galen's audio here. First time doing this stream together. Guess. Yeah. Give me a second. Maybe it's just. Oh wait, no. I can hear you. Yeah, let me just. Yeah. He says thank you. We'll get his mic working here in a second. Yeah. Oh, advanced audio properties. Oh, okay, maybe this is something. Guest camera 1. It's the same genre. Turn it down a little bit, maybe. This is very bizarre. So, can you talk? Yeah, 'cause I don't see your audio even coming through desktop audio. So it's like this isn't sharing. No, it says here you're my guest. I'm the one streaming, so here, give me a second. Say something. Feeling? Okay. Now they should be able to hear you now. It's just gonna share all my desktop audio, but I think that's the only way. I think that's normal. I'm used to hearing desktop sounds from streamers. Like it. Okay. All right. We'll go with this for now. Yo. Give me a second. There's something I think I gotta do. Give me a second. I have an idea. I muted myself, that's why. I was talking to Kat, he couldn't even. Yeah. Yeah. We might just have, hello. Yeah, it's fine. We're gonna have to deal with that. Yeah. Yeah, and that's because you're listening to me through the stream. So I need to be able to send it to you through stream um, together, but for some reason it's not letting me select my mic, like it's giving me permission issues. So in that, you know, with time in mind, I think we can deal with a 2-second lag. It's fine. Slowly but surely, we will become master streamers. All right. Let me just check something here. All right, so show what I've kind of been working on the past couple weeks. Give me a second here. Open up a new browser window here. Why is it not? That's annoying. Here we go. All right. All right. So I'm going to walk through this application that I've created using Haskell. I first was trying to use Python for this application, and it just kind of got really hard to manage different side effects and the basically just really hard to control the actual control flow. And there were some benefits to using Haskell that I'll get into. What I'm using on the front end here is called Reflex FRP. So it's basically it's a library that's quite similar to how the React framework started in like intended. It's basically like React without all the bloat, is the way I like to think about it. And it leverages like functional reactive programming. So it's effectively a declarative style of declaring your events in Haskell. So yeah, it's really nice language to use on the front end. As you can see, like we're using Tailwind. I've got the TradingView lightweight charts view here, and yeah, Reflex has been great for any kind of front end stuff. Basically everything I try to do on the front end kind of just works, which is great. Also, the front end is really not important for this application. So for a lot of this stuff, I've been mainly just kind of using Claude to generate these structures. And because I've got that shared type system that I've defined, like I've defined all my types very cleanly and neatly, it just one shots all of these UIs. So there's like it would almost just be a waste of time now for me to write these UIs. So let's get into it. So I've got the server and the client running right now. So I'll just connect here, and we'll kind of just see what happens, so that I can explain this, because some people get a little okay. So what this is doing, it's easier to kind of. So basically, what I've done, and I'm working on actually some optimization right now. It used to be a bit faster. But this is still quite fast. I can explain exactly what this is doing. So basically, I've fed in 5 years worth of Bitcoin price data. So I have a 10 gigabyte spreadsheet of second by second prices. So open OHLC candles, like open, high, low, close. So I've got 10 gigabytes of that. So spans about 5 years of data. And so what I'm doing with this approach, there's kind of two different trading approaches. You can either do reactive based programming, or reaction trading, or predictive trading. Um, Predictive trading is, in my view, a little bit like it's better for like long term, but predictive trading for day trading is kind of hard to it's hard to tell what way the market's going to go at any second. And if you're doing day trading, that's kind of what you're looking for. You're not really, you don't like, yeah, it's great if you guess that Tesla's gonna. I think basically anyone could make an educated guess saying, okay, the probability that Tesla and Nvidia going up over the next 2 years is pretty high. So I'm going to put my money in there, and that's a good way of investing as well. And that'd be more of a predictive style of testing. With this effectively what I'm looking to do actually is to react to price invariances in real time. So what does that mean? So without getting too into the trading strategy, as well as like I don't want to give away all the beans for free. Um, what what do you need to do to actually accomplish something like that? And ultimately, I think it doesn't matter what your strategy is. I think the first step, of a of any simulation like this is to be able to actually test your strategy over a long period of time, right? So I'm taking effectively the server here is iterating through each second, and it stores a historic. So I'm keeping a historic snapshot every iteration through the loop of all of the candles that came before it, and kind of rolling those up as they go. And so then basically each one of these candles is aware only of everything that came before it, and obviously not of anything that came after it. So with this in mind, we can effectively treat every time I click connect, we can treat it as if I'm simulating this. In this case, it simulated 12 days within I think that was like within a minute. So that's kind of the idea behind this. And then what I'm now working on now is actually finding different signals. So this here is a fair value gap, and I'll answer your question about the pricing invariances now. This is effectively like what we're looking for. If anyone wants, actually, I could give like a quick tutorial, because it's not like I'm a master in this stuff. I would suggest, like, if you are interested in reactive trading, and it's called ICT. I forget specifically what that actually. What is ICT? Inner circle trading strategy. It's basically leveraging the fact that you don't. Okay, so it's maybe a different way of thinking about trading. The idea is that, like, you don't ever actually know what's going to happen within a day. Like, you can't actually know that, unless maybe you have like some insider information or something like that. But that's the key. We can actually leverage the fact that there are these large inner circles of people. That's why it's called ICT, inner circle trading. There are large inner circles of traders that do impact the market, right? These are, traditionally people might call them whales, right? Whales do impact the market. They make splashes. And so what what that means is that they cause, I think I said invariances earlier. I always get that mixed up. Basically, it causes variances in the market that are not explainable by normal trends. So like, for example, like let's just say our trend, like let's just say higher time frames hold higher power. So if I like go to the 1 day, okay, this is like kind of a downwards trend. Like kind of, it's kind of crabbing. It depends what happens next, but let's call this a downwards trend. And then we come over here and we've got still a downwards trend. And then, we come in here and okay, so our overall trend is down for this time frame, right? But then we come here and we see this massive candle, right? And so what is this candle? If we think about this, the psychology behind why this happened, or like the psychology and I guess really just the economics behind why this happened, it's because there were a bunch of people with resting orders here, or I have to think some like depending on the direction, this stuff still kind of messes me up. And I'm coloring these purple, by the way, because I'm any signal that I've detected as a signal, I'm coloring purple. That's just for me testing right now. That shows me that, for example, this candle is not actually working properly, which could come down to a couple of reasons. It's because, which is probably likely the threshold, but anyways. So basically what this means is that there is a gap here. From this price, from this value to this value, there were no, so this is, the price is going up, meaning there were not enough sell orders to create down, or to offset the upward pressure. So there was not enough downward pressure to offset the upward pressure. Now, why was that? That's because when this moment hit here, there were a bunch of stop losses or take profits or whatever, based on whatever direction. And once those got hit, a ton of money either just entered the market or left the market all at once, right? So why does that matter? And why can we do, like, how can we leverage that to make money? Well, it matters because these inner circles of traders know about this. They know that as price rises, there are people who are shorting that price, who are getting closer and closer and closer to their stop loss. Now, if they can determine at which pricing points most people have put their stop losses, they can make splashes, they can influence the market to go in that direction, to hit those stop losses, and then you get these massive candles. So what does that tell us? Well, it tells us that if this massive candle is, they call it a fair value gap, is in the opposite direction of the trend, there may be a future trade here. And if you notice, there was. So this one here basically was signaling that, okay, we're in a downward trend, but there's a huge variance in price moving upwards. So let's keep this on the radar, and let's watch for price to tap back into it. So it taps back in, comes back up. Usually with a fair value gap, it taps twice, which is actually hilarious because it literally did here. It taps twice, and then it falls through. So basically the trade would have been, you come up here, soon as we tapped in, came back here, and then as soon as we had a change in, so the buy order probably would have been around here, because that's when we broke structure from this previous low. We would have bought right here, and we would have sold the difference right here. So that would have been about a 5,000 point, or 5,000 US dollar trade there. And if you're leveraging it, well, good game. Now that's a perfect world, right? The question is now, how do you do this with like market data that's just freshly coming in? How do you make the profit, the strategy actually profitable, et cetera, et cetera? And those are questions that I'm still trying to answer myself. I have ideas, but ultimately what I'm building here is to be able to test out those ideas, right? So right now, the only signal type is fair value gap, but there'll be other signals, and then you can assemble. Okay, well, what happens if I have, because I've got settings here, right? So what happens if I change the minimum fair value gap percentage? And this is something that we might work on today, because it's not working perfectly. But like you can see here how there's like there's a lot more candles. You can actually see on the 1 hour time frame, there's 48 signals that were detected. Some of these, as you can see, like that's not actually a fair value gap. It's like basically it's any time where there's a gap. And what a fair value gap is it's when it's a 3 candle pattern, and when the top of the wick of the first candle and the bottom of the wick of the third candle, if there's basically, this is seen as a gap because there was just so much pressure in the one direction and not a lot of pressure following it. Basically, not a lot of opposite pressure following it. So what that means is that all these orders sold or bought, and there wasn't anything to oppose it. So that's why we measure them. But yeah, here the threshold amount is just set way too low. Like it's basically, if it's like 0, if it's anything greater than 0, it's choosing it. So if I go in here, and I think if I set it to that, this is why I say it's not accurate of a value. But now I'll get much less. And you can see it's also running faster. So the signal detection does take time, and so I'm working on that. Like when it does detect a signal, there's some processing it does. But you can see here now it's a lot more, it's only finding 8 signals here. So that's kind of where the tuning comes in of like, and the idea here is that this should tell me after, okay, I made 13 trades, 6 of them were successful, 7 of them weren't. And then you just play with the variables until you find a strategy that works, and then you run it. So that's the thought here. So what do we, if we can look at the code maybe, I want to start maybe with like just a small goal of something to like change or add. If I look at these candles here, so maybe that's like good. Actually, no, that's not. I think of, okay. Something we can do. Hey, C Films. Good, how are you? Okay, So now, actually gonna change. Okay. Okay. So I think what we'll do, because right now I've just kind of got the threshold for a fair value gap. Like it's a static number, and that static number doesn't actually mean anything, and it's just really hard to use. I think fair value gaps there's an actual algorithm for it, so that might be a good idea to just kind of like look into how we're currently doing it, and then try to update that to a more accurate thresholds algorithm. I know that it's ATR, I think was the algorithm compares the gap size to the average true range. I think I've heard of ATR. The bullish fair value gap is completely breached by a downward move. It can act as a bearish or inverse fair value gap. The algorithm detects this shift in it. No, that's too much. That's gonna go against my other. Pardon? I'm looking. ATR is something I've heard. Yes, it's ATR is something I heard of earlier, but we need a better. Basically, the fair value gap threshold is not like, it's literally just like a float. Like it's like, is it less than or greater than this percentage? And I'm not confident in how it's finding it, because basically even when I set it to like a very low percentage, it's not finding certain ones that I think it should. So basically there's a bug in the threshold mechanism for detecting a fair value gap. And so we're going to look at the actual. Pardon? Yeah, I want to solve that today. Yeah. Because I feel like it's a small enough kind of thing that we can take a look at, and that'll show kind of how some of the code works as well. Yeah. That's not even ATR based filter. Yeah, see, everything's just gonna be like Google's just giving me all the like, yeah, it's giving me all the trading views stuff. Like, where's my boy Claude at? Yeah. What is ATR based fair value gap filtering, and how and what is the I guess it's probably gap filtering, and what is the math behind it? This captures gap. I'm reading at the moment. Yeah. Yeah, so I'm trying to think whether, because it's saying something here about actually, yeah, I think this is what I want. A 1 hour ATR filter will naturally accept different absolute sizes than a daily ATR filter. Yeah, so I want them to be, because it needs to be time frame agnostic, and that might be part of what's kind of going wrong. So yeah, this seems like it could be what we want. So we need to first define the true range, and I have all of this data. And then smooth moving average over n periods. Exactly 14. What is a period though? That's okay. That's just gonna be like each candle times, like each time step, I guess. Yeah. Okay, we can try it. Gonna throw this up for reference. Sorry. Yeah, I forget specifically. It's just very simple. We can look at the code here in a second, or I'm actually gonna just bring it up. We'll walk through it from simulation, just to kind of show, to walk myself back through the code as well as kind of give everyone else. 60 to 70% done. That's ambitious. It's maybe 10% done. What we're working on, the first part is like the visualization is maybe 50% done, but not even, because there's a bunch of other things that we need to add in. Like fair value gaps is just one type of signal, right? There's also liquidity void or liquidity sweeps. We need to know trend directions. We need to be able to like the hardest part is going to be accurately detecting break of structure. That's like the most important one and the most difficult one to do, but yeah, but the difference is you've actually got about 6 ranges that are all like layered on top of each other, I guess. Like you've got, like, you place trades on the 1 minute timeline, and you use the 5 minute and 15 minute timeline to decide to place the trade, and then you use the 1 hour, the 4 hour, and the daily time frames to determine the trend direction. And so you kind of, and then you're overlaying all of that information to determine whether the change in price that you're seeing right now makes any sense. And if it doesn't make sense, there's probably a trading opportunity there. And so it's about now picking the right entry, right? Because you could know exactly what's going to happen, and then you just enter at the wrong time, and it wicks up and you're done, right? So there's a lot that gets into it at that point, and that's where the actual challenge comes in. That's why I'm like, I have no problem showing people this code, because if you guys figure it out, just remember who showed you this. That's all I'm saying. No, there's a lot, like the hard part is still yet to come. Is kind of what I'm getting at. But this will ultimately build us up to that. Like by the time the hard part comes, we'll know exactly how everything works, and it won't actually be that hard. Okay, so the way that this works, I'm using a conduit. If anyone has ever done any kind of streaming, like Conduit is extremely powerful. It is effectively a lazy pipeline that, like, I think of it as like a funnel that like one end is a vacuum where it's like sucking all the data through it. And so like unless the cork is let out from that funnel, nothing will happen. And that's kind of the way I think about the data streaming, is like it will go as fast as it can based on the whatever the last thing you have is in the conduit pipeline. And what it does is it ensures that all processing occurs in order. And so oftentimes with like really high throughput streaming, there can be worries about, like, especially if you're like mutating things, there can be worries about like breaking that state, that chain. And so this conduit T type here, this monad, makes it so that if we can actually look at it, I think maybe a good idea. Google. Haskell for this project, absolutely like phenomenal. I would not want to do it in any other language. And there's a bunch of reasons for that. Yeah. Yeah, if you have any questions as to why, like, there's so many, I could talk your ear off for hours, and I'm happy to. But yeah, it's really just with stuff like that's so complex, especially with any kind of like financial stuff, where there's also the aspect of like, if this thing's going to be making trades for me, I want to understand every single possibility that it can do, and in a Python program, that's just not feasible. So that was like that. That's like one reason why. But yeah, also just it can tell me when things are wrong, right? So that's kind of nice. I'm also able to decode a lot of this information into the type system. So just as a quick aside, like, thank you. In the sorry, I just moved everything into I just reworked everything. Market, handle, time frame. So I've created these types and type families to effectively do a lot of programming at the type level. And so because I have these types defined and these type families defined, I'm able to do things like, for example, you should not, so I can make it impossible throughout my program to accidentally add a price from the 1 minute time frame to a price from the 5 minute time frame, right? As an example, right? These are no longer just like, a price is no longer just a double, right? It's a price TF1S or a price TF5M. And that's relevant because all of the functions that we write are oftentimes time frame dependent, and even like things like this, like deciding what time frames can roll up to another. This is something that you kind of wanted to be defined in one place, and you want this to be a rule throughout the entire program. So I can define that at the type level here, right? And so how does that actually get used throughout the, like, this looks nice maybe, but why is it useful? So I can get into, let's define what a candle is. So for a candle here, I have, and I still haven't switched over so this is actually not finished yet now that I'm thinking. I thought I had done this part yet, but no. But effectively what this will be though is, instead it'll be candle price TF. I was initially going to go like candle open, candle close, but we do want to be able to add candle open with candle close. So candle price is a better generalization, but I haven't done that yet, so that's fine. We'll just leave it. But that's effectively what that's saying, right? Is it's saying, okay, this, yeah, okay, it is a double, but specifically it's a candle open. And so if we look, this is using new types here for the candle open, and we're just saying candle open is a double underneath the hood, but we're not ever going to actually use that double. Okay, and this is where Haskell gets really powerful. Is honestly with these new type constructors. You can almost, I like that these are, yeah, it's a type, it's like a new type construct, it's a type constructor for double almost, right? But like it's really, it's a new type. So it's now the type is actually candle open, but we can write instances and we can actually just derive default instances, because it's a default instance will just look at whatever is here, and if it can figure out, if double has ORed, then it's good, right? We don't need to specify how to do ordering for a candle. This is very different from object-oriented programming, where you have to explicitly define this in every case. And so that's honestly one of those things that, because you have to explicitly define all of this in object-oriented programming, like I don't know if I've ever been at an organization where they actually leverage things like overloaded operators and these kinds of things. Like even function overloading oftentimes is not actually leveraged the way it should be. And I think it's honestly because it's a pain in the butt to do. Whereas here, any type that we create, we can just very simply derive different functionality. And so this candle open now just acts as a double, but we have the extra layer of functionality to say, okay, and well, no, this candle belongs to this time frame, right? So the time frame here is a type variable, or this specifically is a type variable. And this is being used in a, correct me if I'm wrong, but believe this pattern is a gadet. No, it's a higher order type, but it's generalized on the type of TF. Yes, I think it is. But yeah, so okay, so I have I don't want to spend too much time on this. I've got that candle. Basically, the time frame is attached to the trading candle at the type level. So from this point on, no mistakes can be made in that regard. And so that's one of the big powers of Haskell with anything financial related, especially if it's financial infrastructure. That's kind of the way I like that, because a lot of finance uses Python, and I think it's probably fine if you're writing Jupyter notebooks and you're doing data analysis. You could use Haskell for that, and there's probably some benefits to it. But particularly where this comes in is with when you're doing infrastructure and you're creating rules that need to be followed throughout the entire system. it's probably one of the most expressive languages to do that, and has like so much power in that regard. So here I'm just determining instances for CSV, JSON, and that's just the candle type definition there. Then we've got our candle series, which is basically just a sequence of trading candles. And so I use a basically I push to the start of the candle, so or to the start. So all candles get pushed to the start of it because we're always going to be looking from start to older. So that's just an optimization. And then yeah, it pushes the candle with a max length. So I only store 1,000 candles at a time. I probably don't even need to store 1,000. I could probably store 100. And that would probably be enough to make accurate trades because of the way that we're doing candle rolling. In theory, I actually only need to hold 60 1-second time frame, or 60 1 seconds, 5 1 minutes, 3 5 minutes, but it does help actually having more than that in case I'm doing like a trend analysis on that time frame. So really it's like you want to just hold as many candles on each time frame that you need to do trend analysis for that time frame, right? Like if I'm doing a trend analysis or doing some kind of analysis on the 5-minute time frame, like I'm not like at some point there's no longer a value. Like if I'm like 1,000 candles away, like I'm at this point I should be looking at the 15-minute or the 1 hour, right? And so there is a maximum. Finding that maximum right now I've set it to 1,000. If I were able to lower that, it would greatly increase the processing speed of the application. So there's like an optimization I can do in the future, but it's fast enough right now. And so basically, yeah, so then each one you can see here now, this is where we're actually using the data kinds. So you see this little tick here. We're saying, okay, now time frame 1 week is a candle series of TF 1 week. And so now everything in here can be validated at the type level at compile time just to make sure that, you know, okay, we're not adding a candle from this time frame with a candle from this time frame. If we wanted to do that, for whatever reason, we could explicitly write the type signature, right? We can always explicitly write like, you know, I want to go from, you know, my func. I want to go from candle series TF1M to candle series TF 5-minute, right? And you could do this. You can always do this. It's just now it's forcing you to explicitly like it would be impossible to do this by accident, right? You'd have to literally be like, okay, give me all of the raw primitive values from the TF1 minute and then like put them into create a new one called TF5 minute and put them in there. Like you'd have to very specifically do that. And it can't just do that by accident, right? The computer, like you can't just do that by accident. The computer can't just make that assumption based on like, oh well, you know, it's a string here, so maybe he means that we should add. No, it's everything needs to be explicitly defined. And then yeah, market data is literally just all of those time frames. Okay, and then the simulation. Should we be using fixed point values for candles instead of doubles? Absolutely. Yeah, I'm using doubles. It's really only yeah, if I was selling this to someone else, I would definitely, right? It's like you're gonna like floating point issues are they are real. Um, they're more or less relevant when you're doing like a lot of multiplications. Like yeah, I could tell you with full confidence that many financial institutions don't actually use fixed point values. That might scare you, but it's true. It's you have to be very careful about how. Yeah, you always should. Um, you can write math functions to make doubles safe, but no, you just use fixed point. Um, right now, what I'm doing doesn't matter because I'm just looking at like basically if it's the difference between like 0.000001 and 0.00004, for me right now it doesn't matter. There may become a time where it does. Um, now in financial institutions, it does matter. If especially if if they're not careful about how they're doing the math. If they're using a math library that's like specifically designed for money, probably fine. But oftentimes those libraries are kind of they're really doing a lot of that under the hood and then just kind of piping it back to a double anyways. So yeah, it's really about the information theory. The way I like to do it, I just didn't do it. Like the way I would do it is like having a money type, and I think Haskell actually has a defined money type because why wouldn't they? I could be wrong, but safe money, yeah. And so I would probably use something like this rather than rolling out my own money value. Um, it depends on how much you want to how you want to go into it. But yeah, rationals are what you want to kind of use instead of doubles. So do as I say, not as I do for this case. It's kind of doubles make this a lot easier for me. Pardon? Well, exactly. Yeah, yeah. Like, um, basically, what I will say confidently is, yeah. And this isn't going in for an audit, so that's kind of like one of those things that's like, yeah, before the public hits it, you better make sure, and it's easier to do from the start. But that's the great thing about Haskell is I don't really worry about doing these kinds of pre-optimizations because like literally once I want to do this, like as soon as I want to do this, it will be just this. Uh, it will actually be so simple. It will be this. Right. What? Can you talk? Oh, you should be. Can anyone else not hear Galen? Because this desktop audio is coming through and I'm streaming that. Is he quiet maybe? Hello? Talk? Has no one been able to hear Galen the whole time? Try now.
Testing.
Oh my gosh. I thought you guys said okay, well you haven't been talking too much, Galen. That's good.
I've been used to the chat
Yeah,
anyways.
that's good. That's hilarious. My bad. I literally had him muted. But like it was subtle. I had it on monitoring, so I have to
I
do
should have
monitoring and
realized that
output.
myself.
That's all right. We're programmers, we're not Twitch streamers. But we will be Twitch streamers eventually. All right. Okay. Yeah, exactly. The beauty of new types. Like I don't know how you would do this in any other language, and I wouldn't want to. Refactoring is just a pain in the butt. But like literally, this would be the refactor. Like I'm not kidding. You might have to specify like actually. I bet you any money the default instances that they've set up for money. I bet you any money uh, are probably good enough. Has the functional nature of Haskell helped me? Yes, absolutely. I mean, that's, I guess, partially biased because I am now far more comfortable with, like, so I came, just to put it into perspective, I came from an object-oriented background. I learned C Sharp first, C++, did quite a bit of that. I've done Rust, Go, etc. I came from that background, did that for about like 15 years, and then I learned Haskell about 3 years ago. I think I only really became comfortable with Haskell about a year ago. And so for me, yeah, like I think, I mean, it's been like a whole lot more fun. But also I think there is like just without, from a non-biased perspective, I think like based on my experiences from working in object-oriented programming languages, like, yeah, it's much easier to ensure that what I want to happen will happen. I find with imperative languages, like there's the curse of mutation, right? Like you might think mutation is helpful and it makes things easy, but really, like, and functional programming still has mutation. I think that's where it's explicit. It's it's not mutating the value, like it's not mutating any memory. So that's like a different way of thinking about it. It's still immutable from the value level, but you're still making changes over time. Right? Like if you think about it from a timeline perspective, the application is still mutating, right? So this idea of mutable, like it trips some people up, but it's really just like the curse of mutations in object-oriented programming is that you're losing referential transparency, right? Like as soon as I, and by what I mean by referential transparency is like as soon as I start, as soon as I define something that is not, it's like outside of the scope of the current function that I'm working in, as soon as I interact with that value, it becomes unclear to me what happens, right? By just looking at the function. And so then might argue, okay, well, you can control click on that function to see where it goes. Okay, great. Then you get into Miller's law, where the human brain can only comprehend 7 plus or minus 2 logical jumps at a time. And so based on that law of just like how our brains work, object-oriented programs cannot be fully understood by humans. Not from like looking at just the top-down approach. It takes a lot more effort, right? So now you have to go in, you have to read through each of these functions. Oh, does this function throw? Hopefully the library developer added a comment on top of the function that says that this throws an error under these conditions, and hopefully that's accurate, right? So like that's where you get into this, like you start programming, and as you build larger and larger applications, the language starts to become a hindrance to you, right? Like writing in C Sharp, writing in JavaScript, even TypeScript, as your application grows, it becomes harder and harder and harder to manage. And that's just the truth, right? Like that there's like literally systems are built on top of this idea that like it gets harder and harder to manage. Okay, so now we need to, let's make sure we're breaking up our functions. Do not repeat yourself. Like all these test-driven development, all of these different things that kind of like spawn up as kind of side effects of just the simple idea that like your language can't tell you what's going to happen. And so that from that perspective, I'm working with a complex domain of finance and trading. you know, I one day want this to actually take real money and put that into a market, right? So it's like, how am I going to actually feel comfortable with that? And honestly, I tried to build this bot in Python. I got a little bit farther than where I am right now, but then I hit a wall, and I literally, like, any change I would try to make would just cause like random stuff to happen in different areas of the application. Um, and I think it's because you lose this concept of like humans humans are lazy, right? Like I'm lazy. I'll admit it. I'm not gonna sit here and do something that, like, if there's a faster way to do it, that I can do, right? And I think a lot of people have that same mindset, whether they want to admit it or not. Um, and so, you know, like everyone wants to say, yes, types are great for for guiding mean stacks. Yes, exactly, right? Like everyone wants to say, oh, I don't need types. I know how to, types make it harder. This is probably one of the funniest things that I've heard, is that like types make it harder to program, and it makes it like harder to like slower to program. And like maybe um, maybe like certain, it depends on like the language you're using. And I actually think you're probably right if you're using like something like even like C sharp, C++, like in order to get a lot of the real benefits out of the type system, there's a lot of boilerplate. So like I do sympathize with that. So I think, yeah, like that from that perspective, Haskell's just overpowered. Like in the fact that, like, if I wanted to in the future to to refactor this to use money, I literally would just do that. It would be fine. Um, and that same kind of theory of refactoring is like everywhere throughout the code, because the type system is so strong and so expressive. Anytime you change something, it'll either already have the defaults that you need, or it will explicitly tell you at the compiler level that, hey, couldn't find an instance for this, you need to define it. Couldn't find an instance for this, you need to define it. And yeah, that it's been absolutely critical. Okay, so we'll get into the way the simulation works here a little bit, just to kind of walk through the Conduit a little bit, because I think honestly I found Conduit like probably a month ago now, and it's probably one of the coolest library. Like, it just works really freaking well. um, it's this one here. I was surprised by how fast, basically surprised by how well this worked instantly, right? Like I tried to do a streaming pipeline in Python, and oh my goodness, um, it was just not, it was not fast. There were like I was constantly dealing with like file reading and writing issues, and like the file handle being open, and like just all these just weird things, and I have to think about like where the mutations are happening, and then I have to no. So with Conduit, I don't need to do any of that. With Conduit, all I need to do is define Conduit T is what I need. Sorry, where's that? This one. So basically, I'm just going to read through this here. Represents a general component which can consume a stream of input values I. So whatever you put here, I, these are going to be our input values, to produce a stream of output values O, perform actions in the M monad, and produce a final result type R. So for anyone who like might have seen this kind of thing in the past, you know, maybe you're new to Haskell, or like new to like the more advanced concepts in Haskell, this is type level programming. So, you know, we have in Haskell the benefit. This is kind of, I like to kind of think about it almost as like compile time versus runtime, but it's like, so like, you know how in traditional languages you have like your runtime system, your compile time system. With Haskell, you kind of have like three different concepts. The compile time system is broken down into two different perspectives. So like there's the runtime system, which actually runs your application. Then there's the compile time, and compile time has two levels. There's the type level and the term level. So the term level is like things, and basically you can pretty much do anything on the type level that you can do on the term level, right? And so traditional programming is just term level only. So this idea of type level programming is actually quite new. I think correct me if I'm wrong, introduced with it could have been a different functional programming language. I don't want to give credit to Haskell, but this is a functional programming concept. And I think Rust might be like trying to do some of this stuff, but really what this is saying is that we have a type where this type has 4 different generic type variables. And the difference is that each of these type variables, they are fully polymorphic. So the functionality of these type variables is actually defined by the instances and by the functions that integrate that incorporate this conduit. Right. So here we can see, for example, no, I'm not even going to get into that. That's a bit. Yeah. So basically, what that means is we put in our types here. So what I want as my input type is going to be a trading candle TF1S. Notice how I put 1S here. So I want this candle I want this simulation to only ever care about and only ever look at 1 second time frames. If I try to put in any other data this actually does a validation step at runtime too, but the validation step is enforced by compile time. So like if I try to run this on data and not every single field inside of that data is 1 second apart, it will fail. And so that's kind of a nice way to just, I get a quick like validation check that yes, this file is good to go. Every candle is 1 second apart. And then the server sim state, that's your output. So this is basically just a type that has all of the time frames as well as the signals and all that stuff. Then we're just saying, okay, this can work on any monad M, and it returns nothing. This doesn't actually do anything. It's just, I mean, the reason why it returns nothing is because we're using what's called a sync, and so we're sending that out to a WebSocket stream, and I'll show that in a second here. So the way that I'll just actually go to the server because that's probably the best way to do it. Go to networking server. So this is where I've set up the WebSocket. Like this is the full server for handling input incoming connections. This deals with like closing connections in the middle. It deals with everything. I actually really like Haskell for server code. There's some things you need to do because it's a lazy language, right? So because Haskell's a lazy language, you'll notice that's why I'm enforcing strictness on all of my server types. And that's to ensure that when this conduit pipeline runs, that these values are actually here. And that's kind of just a Haskell-ism. Laziness helps us, I would say, in like 90% of the cases. Data.strict map.stricts map. Oh. Cool. I'm going to add that as a note. Note from community. Thank you. Might be faster.
It should actually be pretty easy too, I think.
Yeah, I just don't want to do anything. I don't want to do anything that's going to mess with the compiler right now. Cool. Yeah.
Fair.
Oh, for the unqualified. Cool. Yeah, I'll do that. I'll check that out. Appreciate it. Yeah, so here we have run WebSocket server. Yeah, it's pretty straightforward, but what I wanted to show specifically was, yeah, the Conduit stream. So this is where the whole like Conduit comes in. Basically, as long as I have basically these individual conduits will tell me, like, it's basically, you can think of it like you got your input, output, right? If you remember the simulation conduit's output was a server sim state, and so now the WebSocket conduit's input is server sim state, and the output is void. And so like we're basically just like creating functions by specifying the types here, and it's going to, and so now here our WebSocket sync literally is just getting that sim state, and I'm using a counter to only send, because basically the problem is WebSockets they're a bottleneck in our system, because the WebSocket, like the actual networking speed of a WebSocket is far slower than our simulation speed, and so we don't want to bottleneck our simulation based on the like the speed which the WebSocket conduit can write. And so I just batch them every, I think, 100 or 1,000. Yeah, every 1,000 connections, or sorry, every 1,000 updates. I send out the updates through the WebSocket sync. And so that's something kind of neat to notice, is like when you saw that simulation, every update you see here is actually 1,000 of these 1-second candles happening. Like, it's very fast. It could be faster, but I like it's probably 10 times faster than when I was doing it with Python. And it's because the Python way, I would have had to put a whole bunch of thought into how to make it optimized, right? Like the base, like out of the box WebSocket and like the streaming libraries and stuff, like they weren't forcing me to use them properly, if that makes sense. Like I did my best effort at them, but I'm guessing like it was just not fast. So I'm guessing there was something I was doing that was not optimal. But like, I don't have to worry about like literally run Conduit is all I have to think about here, because the library developers have ensured that, you know, everything I write will be in the like it'll compose correctly. And that's the most important thing, is that when we compose these high throughput streaming functions together, we will not see any emergent behavior, and we will know that everything works efficiently, because it'll just run as efficiently as all conduits do. So that there now gives us the simulation conduit. And so the simulation conduit's quite straightforward. We just take our initial server state, and then it's just a recursive function here, tail recursive, to basically just process candles. So this process candle function is the bread and butter of the whole simulation. So the simulation is literally just give it the state, give it the new candle, and then return the new state. I also really like functional programming just because it really helps to think about all the arguments in this way. You know, I think this is also just a good practice to do. This is just one of the natural consequences of immutability, is that you have to pass in all parameters to the function. But I actually think that's a huge benefit, because it tells you specifically, like, to me, this definition tells me everything that I need to actually accomplish, right? It tells me I'm taking a server state, getting this candle, and I need to return a server state. There's no like, oh, I'm making a request out to the database here to get this value, or oh, I'm getting the mutable child value of this type from like some kind of global reference, or you know, oh, I'm doing dependency injection here. You don't have to think about where all the different sources of your data is coming from. It's all just specified here. So that's another just natural consequence of using functional programming, or I guess a natural benefit, not even consequence. But so what I'm doing here now, this is the candle rolling. I'm just trying to find, it's based on time. We got about 30 minutes left. I want to see what I want to walk into, what I want to kind of get into here. So this is where I'm doing the fair value gap detection. Okay, changed TFs. How did I? Oh, right. Yeah. Okay. Okay. Yeah. Let's look at the detect fair value gaps function. Cool. Okay. So we'll look at just the detect for time frame. Detect for time frame. Okay, so for this one here, we're taking in our gap percentage, and this is where like I'm not huge on how this is working, because it's literally just a percentage. Now, the percentage is probably fine, but we need a better way of applying that percentage. So we've got our market data and we've got our time frame. And so based on these time frames here, we're extracting the time frame from the market data. This could be cleaned up, like, because it's technically, actually, let me see. Because I think I could do that and it wouldn't cause an error, so. That's fine. That'll be a logical error. Okay, so here we're doing detect fair value gap from series. We give it our minimum gap percentage in the series. Series is the whole series. Context, capture candles, 10 for series. Okay, yeah, I remember that. Just refreshing myself so I can explain this. Okay. So basically, if there's less than 3 candles, there's no fair value gap. Otherwise, we get the first 3 candles. And so the reason I can do it like this is because, and this is kind of the benefit of the way that I decided to push the candles, is that everything is newest first. So I can just say, okay, I want the first 3, and I can literally just give them to me as candle 1, 2, and 3. So now I've got the high and lows for the newest and oldest. And so if you remember, oops, let's open up. I think Galen, you posted something to. Ooh, it's a very active chat today. I love it. Yeah, so if we're looking at like what a fair value gap is, just as a refresher of how we're kind of detecting this, we're looking at the high of candle 1 or the low, depending on the trend direction, right? But in this case, this is a positive trend, positive fair value gap. So we're looking at the high of the first candle and the low of the second candle. Or sorry, high of the first candle, low of the third candle. And we are just looking at the size of this gap relative to the price variance. So that's where the fair value gap, like threshold detection, is kind of where we need to incorporate that, right? Right now it's, I believe, just kind of, if this size is greater than X, but that doesn't change, like for example, 5 years ago, Bitcoin was at like, it was like 20,000. Now it went up to 100,000. It's around like 80,000. Like we need the fair value gaps to scale. Like basically, just because it's 80,000 and not 20,000 doesn't mean that this value should change. So it needs to be based on the like the average of the actual. This is where I don't actually know how the algorithm works, but we were looking into it. This is the ATR based filtering, right? So for each candle in that, I guess, okay, so would I get the true range of each candle in the okay. So looks like we're at each candle you have a current ATR value already computed. Okay. So effectively I need to store this ATR then with the candle. That's fine with me actually. So I can do this inside of the roll candle function actually, or like at the same time that I do the candle rolling, and that'll be fine. Okay. So I'm gonna create some function in, where should I put this? Should put it in the types in the common. Actually, no. Well, it is here. Trading market. Technically, just add it to the candle type. I actually don't see a read. That might actually be nice. What would be? Just be a double. Okay. I just This is 2JSON. I think it might just default it. So the thing is like ATR, I don't know if I want to send it to the front end. I can like electively just like not. But I think here is where it will tell me that I need to put it like that. All right, we'll deal with that later. Okay, so I'm adding, basically what I'm doing now is I'm adding an ATR field here. Inside the server, where do I want to do this? So I want to write a calculate ATR function. Probably throw that in the no, this is candle rolling aggregate series window. Aggregate series window here. Okay. Potentially here. Yes, because it's a, sorry, yes. Okay, this is where I want to do it. It is a function that I'm running on the candle series. So it will be like calculate ATR. It will take a candle series TF. It will take an integer for the number of like for its context window size. I forget what they call that. I want to use the actual terminology. Periods. So series num periods. And what do we need to return here? It's a double, really, right? Yeah, okay. It's a pure function. So effectively what this function now needs to do the first thing to do is to get I think I'm thinking about this. I think the TR is what we store. And then the ATR is going to be what we use in the wouldn't it be the TR that we store with the candle and then ATR is calculated in real time? I guess you could technically store both, but like I'd rather store the TR, yeah. Because then you're doing like, yeah, it's better to just use that when you need to. Well, no. Then you're going to be, because you are going to be looking at that candle multiple times, so that would be, let me just look at this algorithm again. Because you would need the TR of every, like you need the true range of every candle in order to calculate the average true range. But then once you've already calculated an average true range, then you shouldn't need to do it again. And each candle should have an average true range, I think. Yeah, because it would be everything that came before it. Yeah, exactly. Okay. So we'll do, for the candle, we'll just add both. But what it will be is TR is a double. But you know what? These should be maybes. Because 0, it could be 0. Like 0 is not actually telling us whether it's computed or not. That was, I should slap my hand for that. That's better. There's a full conversation going on in the chat, trying to keep up, but I'm gonna just move forward. I'm happy I have
Yeah,
my
no.
moderators in the chat. You guys are awesome. All right. So sorry, just trying to get my head back and things. Okay, so we've added the TR and ATR, and inside this candle series function, we are going to calculate the ATR. Just trying to think. Do I want to return it? I'm not going to worry about function naming for right now. This is a function that's going to take in our candle series, a number of periods, and I'm actually going to get it to like return the candle, because there's two, like I could do that, or I could have it return a tuple of doubles, but I don't love that. So we'll just have it like extract the actual candle from the candle series. No, we shouldn't. We're gonna have it return the candle series. My bad. So it is gonna basically update the ATR for the most recent candle in the series, is what this will do, based on the num periods. So basically what I need is I believe it's seek.index, but we want to use a safe method of doing this. So let's just look. Because effectively what we want to do is just get a sample of the previous 14, but we just want to make sure that we have 14. So I mean, short of going like if greater than 14, then I'm just wondering if there's a different way of working with seeks. See, I think this positions out of the range, index fails with an error. I don't like that. Might even just be lookup. Just map, like do,
What are you trying to do? Sorry.
I'm trying to take, I think it could be take even. Yeah, take should be fine. Because it'll return me the sequence. It'll return an empty sequence, and then I just need to, so I'll go like take I, and then if the length of what I take is less than I, then I just return, like, then it's just a no op. I'm trying to make it so that if, yeah, I just basically, I don't want an error to be thrown, right? Like index, if I go index,
Yeah.
it'll throw an
Take is
error, but
tonal.
take is fine, yeah. So that's all I was really looking at. So if I say take num periods series, I think that's the order, yeah. Say let period, or let sample, whatever. Then all we need to do, we need to run a function over this. This is fine. That part's fine. But I want to just make sure. I want to conditionally. I'm doing something. That's what I was supposed to do. Okay, then else it's just series. So here is where we actually do the logic. So this is where we basically just need the reference. Let's go back to the math. I don't care about the code. Okay, so here's what I'll do. Okay. This is going to take a candle series TF, and it's going to return the double. This is what I want. And I also want to calculate TR, which takes a candle series. Or no, takes just a candle. this is no longer called that. I'm just gonna call this like, or we'll just say, I don't want to worry about naming this right now. Okay, calculate TR, take in our handle. This, and this is also like, I love doing this with functional programming, is just breaking it down into smaller and smaller functions until it makes sense, right? So here we've got now, we basically effectively just need to run max on the high and high minus the low. So we need the previous close. That's going to be the difference here with TRs. We've got our current. I'll just say cur and prev. And so we'll take in 2 candles here. And then we'll go, just literally copy this. Okay, so we need the max, which I think is literally just max. I don't know if I need to import that. Give me a second. No, it's prelude. So we go max, high, and low, or high minus low. So what we'll do here now is we'll just say let high equals, or say per high equals trading candle high, cur low, same idea. Okay, so we've got the previous high and previous low. Or sorry, no, we need previous close. We don't care about the previous high and low. We want previous close. I'll just say and because I haven't done this. Oh wait, no, that's just for open and close. So I'll need to do this. Okay, so it's just because I've this is a candle close, so I need to do it like this. From the discussion before, the idea would be to have all of these just be price candle, right, like this. And then we wouldn't actually need to extract the double, we would just use the price cap. But because these two are, it's just, the code isn't completely complete. Because these two are still doubles, I'm just gonna get the double out of here. I don't wanna refactor right now, but this will be a very easy refactor. Once I make all 3 of these types the same. Okay, so there we've got the low, high, low, and we're gonna say in max of the cur high minus cur low. And then this is the absolute value of the cur high. Or no, this is it? That magnitude? No, it's not. Okay. I get mixed up with the bars. Oh, right. They're the same thing. My bad. Okay. So this is abs. It just depends on whether you're doing a vector or a scalar. Okay, so absolute current height minus prev close, and then the third argument is the absolute value of cur low minus prev close. Except that's not valid Haskell. It's not a tuple. Okay, there. That's what I was doing wrong. I was like, what the heck? It's fine. Okay. There's that function, and then calculate ATR is literally just doing just a mapping this function over all candles in the trading candle. It would be, and then returning that. Yeah, so it's not a map. It's a fold. R. It would be it's a fold L prime because I'm just going over the, yeah, that's fine, that'll work. Okay. Calculate ATR. I'm just gonna do this point free, I think. Yeah, we'll just go fold L prime of sorry, what? Oh, I'm thinking about map. It's the function first, yeah. Function, then value. Give me a second here. This is for conduit, so oops. Function is, I don't think I can do it this way.
What you thinking?
Yeah, it's not a fold. Okay, so I need I'm just kind of getting ahead of myself. I need to just call this function with the previous two. So, okay, no. I don't need to call calculate TR because the idea is that calculate TR needs to happen before calculate ATR, but in theory it should have happened for all of the TRs before, right? Like it like every candle that I go over here in this candle series. So I should be able to like basically effectively map calculate TR over this structure. But the problem is calculate TR takes the current and previous, so I would need, first of all, I should swap current previous because I want to be able to, because it doesn't really matter.
It will make the fold a little easier.
It'll make the fold a bit easier, is yeah, kind of what I'm thinking. Because what we need to do, like I'm just gonna not worry about if this is perfect yet, but let's say it's like, it's a fold and the function that we want to fold is this calculate TR, but it needs to be applied to, see that's the challenge. I guess like it gets applied to all of them, and then that gets aggregated. Like, because the problem is the ATR needs to go over, like it needs to go through like say 14 different like periods, right? Like this candle series here is like 14, so it or like X number of candles. So it needs to aggregate those candles and average up the TFs, or sorry, the TRs in all of these candles. Now the problem is, yeah, so I don't want to fold calculate TR over it in calculate ATR. I think calculate ATR needs to run after this, and then just use, like basically it should function under the assumption, I mean it's not gonna, it's gonna have the case for handling the nothing, but it should function under the assumption that there's TRs for all of these. And now that wouldn't be the case for like the first 14 candles, but that's why we're gonna have that nothing case. That's why we've made it a maybe. So we should be able to, like this should be as simple as, and it is a fold, but it's not a fold over the ATR or the TR value, or yeah, it's not a fold with calculate TR. It's simply just a fold of adding together and doing, like it's just an average, like doing the average. So I think actually it's not even a fold, or it would be a fold, and then you would divide it by the, yeah, okay, by the length of the series. So I do need, this can't be point free. That's fine. Or I guess it might be, but I don't know how to write it. Double point free function. Like it's fine.
Probably easier to not do point
It's
free
gonna
on
be
the
easier
line.
at this point. It's gonna be easier and more readable to not do point free, because I would need to like it would, len would also need to be point free, and I don't even want to think about how to do that. So we'll just basically say fold L prime of literally plus, it's not plus, but it is some, if I need to, it's plus composed with the oh, okay, actually I know what we can do. It would be plus composed with the it's the TF, so it'd be trading candle underscore TR. Now this is a maybe, so it would be from maybe, and give it a 0, and that should be fine because we're just going to add up zeros. And that's actually, I think, valid because we would still want those to be included in the averaging if they don't have a TR. But everything's going to have a TR except for the first candle. The very first candle won't have a TR. So will that affect the average? That's the question.
Do you want to use a dot there?
A what? Potentially.
From maybe 0 trading candle to TR?
Yeah, sorry, what's that? I need to, this isn't finished, but.
Well, that's a record accessor.
Yeah, exactly. Yeah.
Gotcha.
Yeah. Because this record accessor accesses the individual elements of the candle series. And then yeah, from maybe 0, that should be unapplied. And then like I'm not 100% sure. I think that's the right way of writing that, but I could be wrong. And then you would effectively want this at total in total divided by when series. Or it'd be seek.length. So there's your ATR. So then in here, we're basically just saying if seek.length sample is equal to num periods, then okay, so this is where it gets a little tricky. Also, yeah, wait, no, that's not going to work because this needs to be the previous.
I feel like you're making it harder by trying to do it point free.
I'm not doing it point free anymore. Or I guess oh, wait. No, you're right. You're right. Well, no. This is just a function for the fold. But like I'm thinking that the fold, it's not really like it's a fold, but I need to actually have access to the accumulator in this case because I need the previous, like, wait, no. Calculate. No, sorry, I'm getting mad. I'm getting mixed up. TR needs the previous. This doesn't need the previous. So here's where I need, so this should be fine. Let's just assume it is for now. This is where I need to now calculate TR. Okay, but I don't need to, this is calculate ATR.
Sorry, Kyle, but I'm going I'm muting for a second so I don't like hear myself twice. But what I'm saying is fold L prime takes that function takes 2 arguments, but you're applying it point free as if it only takes 1 argument. So I'm just saying like expand the lambda.
Oh, sorry.
Might make it easier to think about.
That's what I meant. Yeah, that's what I meant. But that's not what I'm getting confused by.
No. But you still need like fold L prime, like that plus, for example, is like.
I'm composing the plus with whatever this value. So this would be like, it'd be like +0 or +3.
Is being applied to different arguments, but that doesn't make any sense.
Hmm? Okay, that's fine. I'm still trying to work through the logic. Like the compiler
Like, do you
would
know what
tell
I
me
mean by
that.
like expand the lambda?
Sorry? No? Not sure what you're saying.
Here.
Oh, and for mine Trizzle, TR is true. What is it? It's like true range. Yeah, true range. True range and average true range. So it's basically giving us like a range of values that we can trust. Um, to like to say like this is like what the range of the values have been trading in for this time frame. So then we can use that range and can kind of normalize it to the time to the price, and then we can use a percentage to determine like how big of a fair value gap it was. Oh yeah. Okay, yeah. You're saying like turn yeah. That's kind of what I was thinking I need to do anyways too, because it's like
Cause right.
go ahead.
Yeah.
But I also
Yeah. Well, like yeah, because you're applying it as if it's only one argument.
yeah, that's fine. I'm still at the logic. So this is the way I write Haskell is I'm like I don't right now I don't care if this is correct or not. Just to be like full stop. And the reason why is
Okay.
because the compiler will tell me specifically what I've done wrong here. I I guess yeah, like what I'm trying to I'm trying to work through the logic of this part now, and then that will probably tell me the answer to this. Um, because right now I don't even know like don't even necessarily know where to call because TR needs to happen every time. Calculate ATR only happens after the 14th. Um, that passes in the sample. So calculate ATR sample. And that should give me back a double. So I would want to basically set the candles value to almost like you'd almost want to use like lensing or something here. Anyways, hmm, sample. So we don't need this is just for the sample. That's valid, but that will seek.index. I can try, but that'll also throw. It's also gonna throw a 0. Hmm. Yeah. Yeah, I think there's really no other logical way to like I need to get the first and second. This will the problem is no, I can just use take two. That's probably the best way to either way I'm gonna have to check I'm gonna have to do an if statement. Yeah.
We should also start wrapping up, by the way.
Yeah, I mean that's fine. I'm gonna kind of go until I can at least compile this. Okay, so sample, take, period. Preview sample. So we've got the current, previous, sample. This stuff's almost just like, it's only really related to the ATR. So I'm gonna move it into there. It's gonna take the full series. When I say let sample equal take, here I'll say int periods and sample take, okay, and then correct me if I'm wrong, Galen, but laziness should make it so that this is never computed unless I actually return total. Because if that's the case, that's
or you use it in the thing you return.
yeah. But like, for example, yeah. So like to me, that's a huge. Like, I don't even know how I would write this in another language. Like, so I could do, because that means I could do if sequence dot length samples num periods, then I do total, right? Then I go then. Otherwise, nothing, because I made it a maybe double.
Yep.
And I'll have to work out the type signature of this too. But yeah. And yeah, just because of the.
So if it returns nothing, the total wouldn't be computed.
Exactly. I think that's honestly huge. Like that's such a cool way of programming. Because I'm specifying what would happen here, but I'm so used to like you do this, right? And in an imperative language, like, okay, it comes to this line, and next line, like it's executed all of this, right? But no, what I can do is I can set this up to say, because everything's lazy by default, right? So it's saying sample is really just like it's a token. It's like a token to this, or this is the token, and then like, you know, basically if this gets executed, then it has a reference here, but it's only going to actually try to use it if I use this token. And so like in the case of nothing, it doesn't even try to do this doesn't even try to do this calculation, which is huge because we're writing this declaratively, and then we're allowing the computer to figure out the most optimal way to handle that. And so I'm just going to write this function, and you guys are going to, because we're getting to the end of the session for today, but you guys are going to trust that this compiles because you're awesome. No, but I think this here might need a little bit of work, but next week we'll come back and I'll show, like, I'm going to be working on this throughout the week, but next week we'll revisit this section. So let me just finish writing the logic here, but we are coming to the end of today's session. So if anyone has any questions, comments, anything, we're happy to hear it. So here we've got current and previous. And then we want in this actually doesn't matter. So I'm going to keep it like that. There we go. We've got our TR. Maybe TR. No, I'll just do it. So we've got our TR. That needs to now be added to the candle. So new cur equals okay, and then because we need that handle to be added back to the series. Okay, it's getting a little interesting. I need to now add that. I need to swap it back. Can I replace index 0? Probably a set function, I'm guessing. Okay, then we'll do. Sorry, I'm just reading the chat a little bit here and blanking. Let me just focus on this. Okay, so new. I just want seek dot. I'll go to where index is, and it's probably somewhere near. Adjust. Update, yeah. Base element is if the position is out of range, regional sequence is returned. Okay, that's easy. There's ways to clean this up, but that's okay. Update. Oh no, update takes the int, so be update 0. Okay. So then this just becomes. And we basically just do the same thing here now. Now we say new. I'm going to rename all of this stuff, but this is just to kind of get us going here. So new cur prime, or what we're going to say now is our ATR equals calculate ATR. It's our new series. We're going to do 14 periods. And then new cur prime is new cur with ATR set to ATR. And this is just, I'm getting lazy, but this is valid Haskell if you want to write it this way. No problem. Really, ultimately, it's just like I could clean this up with all the different naming and labeling and everything, but that's all it comes down to. So, and this could honestly also be where like using like something like micro lenses or something might be useful. So we've got our new cur, and then we'll say new series prime is just our, as we're going to update. Here we're updating. Yeah, same thing. Update 0. New prime. Yeah, something like that. Now this could be like, as I'm looking at this, I like to follow this idea called semantic compression. So as you basically, you know, you might have seen me writing some things, and if you know Haskell, you might be like picking out like, oh, that's wrong. Oh, that's wrong. And that's fair. If you picked up on all those things while I was writing it, that's awesome. But typically, what I like to typically do is I can now very clearly see that there's a lot of duplication here, right? Like this idea of do not repeat yourself is valid, but it shouldn't necessarily be used as gospel for like while you're writing your code. Because now I've got the logic here, and I can very easily rework this. So by the next stream, I'll show this. It'll probably look completely different. But this, you know, is actually functioning, which is ultimately what we care about. So that's it there. So I'm gonna clean this code up over the week, and then, you know, next week maybe go over this, or if anyone else wants to see anything in specific, you know, feel free to please let us know in the Discord chat if there's anything that you want to see, like specifically, you know, if there's something that you wanted me to do today that I didn't. Yeah, we're gonna be here every week doing this kind of thing, and we're also exploring, you know, other kinds of sessions, maybe for like beginners or like different levels of programming for Haskell programming. So yeah, let us know in the Discord chat what you think, and thanks for joining.
Also, Kyle.
What's up?
We should figure out. There's apparently a feature of guest star.
Guest star?
That would maybe work better. Yeah.
Yeah, I'm not sure the difference between that and stream together, but I'll look into it. Is it a Twitch feature? Or is it a third party?
Yeah. I'm sending you some details.
Cool. All right, cool. Yeah, we'll look into that for next. We'll get the Twitch, the stream will get better and better each time. But anyways, I'm gonna stop the stream. We can chat.
Set up now, or
yeah, we can. The stream's still going, so I'm gonna just stop it here.